In an arresting improvement that has started huge conversations, a new disclosure has separated specialists as they cautiously analyze new information. The much-anticipated breakdown of room disclosures has become exposed, with eminent astrophysicist Neil deGrasse Tyson revealing insight into the spellbinding discoveries in space. Join us as we dig into how Explorer 1 has distinguished 500 baffling dull items navigating space and explore Tyson's insights on this noteworthy disclosure. On June 30, 1908, a gigantic divine occasion happened when a space rock slammed into Earth, affecting a Siberian city in Russia. The sheer power of the crash leveled roughly 2,000 square kilometers of land, sending shock waves across the globe and leaving a global resonance. In the fallout, research started with the distribution of Neil deGrasse Tyson's work on the noteworthy association between space science and the tactical domain, where he contended for the significance of joining logical examination with public well-being. Tyson upheld for greater interest in space investigation as a vital method for shielding Earth from future dangers. His work assumed a critical part in reshaping public discernment about the significance of room investigation. In a surprising development, NASA's Explorer 1 has now recognized 500 dull items traveling through space, leaving analysts both interested and confused. The incredible astrophysicist Neil deGrasse Tyson has arisen to offer wise clarity on this amazing revelation. However, as researchers delve further into the mystery surrounding these 500 obscure items, they accidentally uncover an even more alarming disclosure about Explorer 1 itself. Before we explore this breakthrough, we should initially figure out the significance of the Explorer 1 rocket. Explorer 1, the fearless space Voyager, has already covered an impressive 145 billion miles from Earth. Its speed through space is genuinely marvelous, navigating a distance that is around 3.6 times the gap between Earth and the Sun every year. However, Explorer 1's achievements go beyond speed, longevity, and the huge distances it's ventured. The shuttle has conveyed an array of extraordinary discoveries. For example, the new detection of 500 puzzling objects in space, bizarre and glorious substances that challenge ordinary understanding. You might be considering how a spacecraft sent off in 1977 is as yet working and communicating such significant information. The answer lies in the remarkable engineering and foresight that went into the plan of Explorer 1. One of the key highlights adding to its prolonged life expectancy is its dual redundant PC frameworks. Both Explorer 1 and its twin, Explorer 2, are furnished with two independent sets of fundamental PC subsystems: the Flight Information Subsystems, FDS, and the Demeanor and Articulation Control Subsystems, AACS. This redundancy acts as a critical shield, empowering the space apparatus to continue to function smoothly, regardless of whether one framework fails, while the other keeps on overseeing tasks. The PC frameworks on Explorer 1 and Explorer 2 were planned as a dispersed structure with three double redundant arrangements, further ensuring that reinforcement frameworks can assume control when required. This redundancy is fundamental for forestalling significant framework disappointments. To improve power usage, the shuttle's instruments depend on strategic logic, meaning the frameworks were designed with optimized circuits ensuring operations within the shuttle's power budget and mission time limits. Power management is a crucial factor in maintaining Explorer 1's functionality, particularly given its distance from the Sun, which limits its capacity to harness solar energy. Engineers had to develop clever strategies to maintain power efficiency. One significant technique involves shutting down non-essential systems and assessing which subsystems can be deactivated without affecting primary mission objectives. For instance, radiators for specific scientific instruments were turned off to reduce power consumption, thereby extending the spacecraft's operational life. This decision is made after careful evaluations of the impact on both the shuttle's power conservation and its scientific mission goals. The goal is to strike a balance, ensuring maximum power efficiency while preserving essential functions. Moreover, Explorer 1's power management system adapts to its changing environment. As the spacecraft ventures farther from the Sun, it experiences a decline in available solar energy. To counter this, Explorer 1 adjusts its power consumption to maintain essential operations. Over the years, engineers have continuously improved and refined Explorer 1's power management techniques, resulting in better power distribution, enhanced battery charging procedures, and more efficient power regulation. These updates have played a critical role in extending the spacecraft's operational life expectancy, allowing it to continue gathering data almost 50 years after its launch. A remarkable accomplishment considering it was originally expected to last only 5 years. This longevity is a testament to the dedication and expertise of the scientists and engineers who have maintained the rocket. Despite this careful planning, the vast uncertainties of deep space still present unpredictable challenges. Stay tuned as a crucial discovery is about to unfold. What exactly did Explorer 1 find? While there are assumptions that it may have encountered meteoroids, space debris, or other celestial objects, the possibility of astounding discoveries remains. One of the most striking events in the Explorer 1 mission was the recognition of 500 unidentified objects, which set off widespread concern and deep curiosity. Explorer 1 began transmitting telemetry data back to Earth, but the readings were perplexing, with no clear explanation for what was occurring. Experts initially considered the strange signals to be mere anomalies. However, despite occasional transmission errors, Explorer 1 continued responding to commands from Earth, though with some delays. What was most surprising about this situation was that it didn't trigger the spacecraft's fault protection systems, which are designed to activate when anomalies occur, putting the space apparatus into test mode for troubleshooting. Despite these peculiarities, Explorer 1 continued to operate normally, which only added to the intrigue. Upon further examination, the anomaly was traced to the spacecraft's Attitude and Articulation Control Subsystem, AACS, which manages the rocket's orientation and movement. Given that there is around a 22-minute delay for radio transmissions to travel between Earth and Explorer 1, communication posed a significant challenge. Despite these hardships, the mission team successfully rerouted telemetry data through the functional onboard computer, and the system began transmitting clearer, more precise information about the space environment surrounding the rocket. With the anomaly resolved, the research team focused on analyzing the data from the rocket. Incredibly, they discovered that among the 500 unidentified objects detected by Explorer 1, a subgroup exhibited highly unusual properties. These objects moved erratically, had irregular shapes, and displayed odd spectral signatures that did not match any known celestial phenomena. Initially dismissed as noise or interference, further analysis revealed consistent behavioral patterns in these objects, which defied conventional explanations and challenged current models of space dynamics. This discovery ignited heated debates within the scientific community. Some proposed extraordinary theories, including the possibility of extraterrestrial life or advanced technology, while others leaned toward more conventional hypotheses. Considering these findings, Neil deGrasse Tyson shared his perspective in a series of interviews and public discussions, advocating for a cautious, methodical approach to the investigation. Tyson emphasized the importance of maintaining scientific rigor and avoiding rushed conclusions, encouraging researchers to gather more data before drawing definitive conclusions. As scientists continued their efforts to study the perplexing objects detected by Explorer 1, they utilized observatories, space telescopes, and ground-based instruments to gather additional data, working collaboratively to piece together the mystery. Gradually, they began uncovering clues about the origins and behaviors of these enigmatic objects. Although many questions remain unanswered, each new discovery brings them closer to unraveling the true nature of these cosmic anomalies. The identification of 500 unidentified objects by Explorer 1 marks a significant milestone in space exploration, challenging our understanding of the universe and opening new avenues for scientific inquiry. By studying these mysterious anomalies, researchers hope to uncover the universe's secrets and deepen our understanding of its vast and complex nature. This revelation has not only captivated the scientific community but has also ignited widespread curiosity worldwide. It represents a pivotal moment in our quest to comprehend the cosmos, pushing the boundaries of what we know and expanding our perspective on the universe. As analysts continue analyzing the data sent back from Explorer 1, the potential for groundbreaking discoveries seems limitless. While some of the identified objects may eventually be explained through conventional astronomical phenomena, the fact that many defy existing theories and models adds to the excitement of the mission. Explorer 1's findings underscore the dynamic nature of space exploration, where even the most unexpected results can lead to breakthroughs in our knowledge.